Right, so this is a solutions video for the review paper that I gave you for your quiz on solving systems using algebra, either by substitution or by elimination. All right, this first two problems say to use substitution. However, it can be done in either way. So I told you that you could use either method. You just can decide whatever's easier for yourself. So I'm going to show you a few that I think are kind of classic substitution problems. If you look at number one, this has an x by itself. A variable by itself tells me this is substitution. So I'm going to take what it says x is, 7y minus 4, and I'm going to stick it in the other equation where x was. So basically, I'm just going to rewrite that equation, the second equation, except instead of an x, I'm going to put the stuff from the other problem in for x, like this, in parentheses. And then I'm just going to continue writing the rest of the equation as it was. So with this, now I've basically got it down to a relatively simple thing to solve. I'm going to distribute this stuff. I get 14y minus 8 minus 3y equals 14. That's distributed. Now I'm going to combine like terms, 14y and negative 3y, that's 11y minus 8 equals 14. And I'm going to do a quick solving for y here. I'm going to add 8 to both sides. And then I'm going to divide by 11. And I get y equals 2. Okay, I'm not done. I have to go back to my original problem to get x, because you need both x and y. So I'm going to take my answer for y back up here and put it where the y was in this equation for x. So really what I have, and normally I wouldn't write this, is x equals 7 times 2 minus 4. In other words, 14 minus 4, x is 10. So my final answer to this is 10, comma 2. Always a coordinate point as a final answer. So number 2 looks like it could be substitution, although it also looks like I could see elimination too. I think the easiest thing to do with this one, and again there are several ways, because you want a variable by itself, I see there's 2x here. If I just get rid of the 2, I have x, that's fine. So I'm going to divide everything by 2. So what I really have is x equals 1.5y plus 3. And now I no longer need this. So I'm going to stick this x value stuff, this, in for x up here. So what I really have when I rewrite my equation is y minus 3, and then in parentheses 1.5y plus 3, and then finish writing the equation equals 5. So I got to distribute here. I get y minus, that's negative 4.5y. Negative 3 times positive 3 is minus 9 equals 5. Again, combine like terms here. 1y minus 4.5, that gives me negative 3.5y minus 9 equals 5. Okay, now I'm going to do some simple solving. I'm going to add 9 to both sides. See, as you're getting farther along in algebra, I'm assuming this is stuff you know how to do. And then I'm going to divide by negative 3.5. Now, because I'm dividing by a negative, a positive divided by a negative is going to give me a negative number. And 14 divided by 3.5 turns out to be 4. So actually, y is negative 4. Okay, this one, I'm going to take my negative 4 answer, and I'm going to come back to the one I had solved out for x, and put it there. So I got x equals 1.5 times negative 4 plus 3. So 1.5 times negative 4 is negative 6 plus 3. X is negative 3. Final answer, negative 3 comma negative 4. All right, number 3, again, same kind of thing. I'm looking for something I can substitute. But as you can see, I don't have a variable by itself. Although right here I have a y. If I could just get rid of this, I'd be all right. So I'm just going to add 2x to both sides of this bottom equation. That'll cancel this. And I just get y equals 2x. Well, that's easy enough. So with my 2x here, I'm going to substitute it where the y was in that original first equation. So I'm going to have 3x minus 4, and then finally in parentheses, 2x equals 20. So I'm going to simplify here by distributing. I got 3x minus 8x equals 20. That's negative 5x when I combine like terms equals 20. One step, divide by negative 5, x is negative 4. Okay, this one I don't even think I have to write out for you. Here's x, negative 4. Up here, y is 2x. So 2 times negative 4, y is negative 8. Final answer, negative 4, comma, negative 8. Those three are all substitution problems where you're sticking one equation into another. As you can see, all the work is done in getting the first variable, and then the second variable comes pretty quickly. In the case of number 3, we didn't have to write it out. It was so easy. Okay, numbers 4, 5, and 6 deal with elimination. They tell you that. So again, if you like substitution, you can work these substitution ones, but elimination is usually a much easier method. So I'm looking at number 4, and I'm trying to think of something that I can, when I add these two equations together, column by column, I want something to cancel out. Hopefully an x term or a y term. So if I look at this, it's pretty hard to turn a 5 into a 6 or whatever. But right here I got an x and a 3x. If I could just make this x be negative 3x so that when I add it to this it would cancel, I could get it to work. So basically what I'm going to do is I'm going to take this first equation and I'm going to multiply the whole thing by negative 3. I'm doing that so I take negative 3 times x, I got negative 3x. I got negative 3 times 6y, that's negative 18y. Negative 3 times 1 is negative 3. So what that does is it allows me to cancel out this whole beginning equation and use this one, sorry about that, use this one and the one I didn't cancel. I'm going to push them together now. I'm going to add column by column. So 3x and negative 3x added together, cancel. 5y and negative 18 added together gives me negative 13y. Negative 10 and negative 3 added together is negative 13. Simple solving, divide by negative 13, y equals 1. Positive 1. So if that's the case, then I have y, I need to go back and get x, just like the other problems. So I'm going to take one of these equations, I'm just going to use this one right here, put 1 in for y. So what I really have is 3x plus 5 times 1 equals negative 10. In other words, 3x plus 5 equals negative 10. I'm going to do some simple solving. Subtract 5, 3x equals negative 15. Divide by 3, x is negative 5. Final answer, negative 5, comma, positive 1. So again, I'm looking to do that in number 5. I'm looking to add the equations together so that they cancel. Or at least one variable term cancels. But I don't have anything in number 5 that's particularly easy to do that. 2 into 3, 3 into 4 doesn't really work very well. So I'm just going to pick one of the variables and say that's the one I want to make cancel. So in this case, I might actually have to multiply both equations. So I'm just going to try to cancel these x's. For no reason other than just, I don't know, I feel like canceling the x's. So I'm going to take this one and say, look, 2 times 3, well, if I multiply by 3, I'll get 6 here. So I'm going to multiply by 3 here. And for the second one, I'm going to multiply by 2, but not just 2. Because I want one of them to be negative, I have to make one of these negative somehow. So I'm going to choose to actually multiply this one by negative 2. So the top one's going to give me negative 6x, negative 8y, and negative 12. And the bottom one is going to give me 6x, there's the stuff that's going to cancel, plus 9y equals 9. So actually, I don't need either one of those original equations anymore. I can use these two. So let's push them together by adding. These cancel. This is negative 8 plus 9 actually gives me y, or 1y. Negative 12 plus 9 is negative 3. Turns out y is negative 3 with no real solving needed. Okay, take your answer for y. You can actually use either these two new equations you wrote or even one of your old equations. I'm going to use an old equation because this 2x plus 3y equals 3 looks really nice and easy to me. So I'm taking this equation, I'm just going to put negative 3 in for y. So 2x plus 3 times negative 3 equals 3. 2x minus 9 equals 3. Add 9, I get 2x equals 12. And so when I divide, I get x equals 6. Final answer is 6 comma negative 3. We have basically the same situation in number 6, where nothing really works too well together. So I'm again going to cancel the x's because they're the lower numbers. So I don't care which one I cancel. It just so happens to be that one has the lower number. So it's actually almost exactly the same as the last one. I'm going to multiply this one by 3. I'm going to multiply the top one by negative 2. Again, so that this will be negative 6 and this will be positive 6. So the top one's going to give me negative 6x, positive 10y, and negative 2. The bottom one is going to give me positive 6x, positive 9y, and negative 36. I'm going to add them together. These cancel. This gives me 19y. This gives me negative 38. And in one step dividing, I get y equals negative 2. So with my answer for y, again, I'm going to go back to one of the original equations because they seem to be a little bit easier. I'm going to pick that bottom one again. 2x plus 3 times negative 2 equals negative 12. So 2x minus 6 equals negative 12. I'm going to add 6 to make that 2x equals negative 6. Then I'm going to divide by 2 to make it x equals negative 3. Final answer, negative 3 comma negative 2. Halfway done. Okay, the last 6 problems, specifically on the paper, say choose your method. Most of the time, it seems like people try to choose elimination because they got it in their head that elimination is easier. I can understand why you say that, I agree. But it's easier for certain types of problems and more difficult for others. So we're going to look for problems that seem to be easier for elimination and problems that seem to be easier for substitution. So I'm looking at number 7, and I see x's, y's, and numbers lined up. To me, that says elimination. I just got to make sure something cancels. So I don't know, I'm looking at this and I see I could turn x into 2x, but I need it to be negative. Or I could turn y into 3y so that it would cancel this. So it doesn't matter. I'm going to go with, in this case, I'm going to go with canceling the x's just because I feel like it. So I'm going to multiply by negative 2. So that this will be negative 2x, negative 2y, and negative 26. Don't need this one anymore. You know what, I'm going to back that out of that, because I might actually use that one. But nonetheless, I'm going to use these two equations now. That's going to cancel. This is going to give me negative 5y. And put these together, I'm going to get negative 25. So y, when I divide, y is 5. Alright, actually I got a really easy equation to use. Let me use this original one up here. X plus y equals 13. In other words, x plus 5 equals 13. Okay, x is 8. So my final answer here is 8 comma 5. That would seem kind of easy. Okay, for number 8, I think people, because if you notice the last few problems we've done, we've canceled the x several times in a row. That's okay. In this case, you could cancel the x's too, but I think this time it might actually be easier to cancel the y's. you look at it here, I got -1 and +2. I just want to turn this into a -2, so I'll do that by multiplying this whole thing by 2. So I got 6x minus 2y equals -20. And now I can combine the top equation and our new one. That's 15x. These cancel, and I got -15 over here. Turns out x is -1. Okay, so I'm going to go to, again, doesn't matter which one. I'll just go to the top equation, and I'm going to put in, for x, a -1. So I got 9 times -1 plus 2y equals 5. So this is -9 plus 2y equals 5. Get rid of that -9 by adding it to the other side. So I got 2y equals 14. And then I divide by 2, I get y equals 7. So my final answer here is -1, 7. Almost done. Okay, number 9, if you're looking at it, we don't have the x's, y's, and numbers lined up like we did in the other problems. In fact, I've got an x by itself. To me, this right here says substitution. So I'm going to take 5 plus y and put it where x was in the other one. So what I really have is 2, and then in parentheses, 5 plus y, and then another plus y again. I'm recopying the equation. Plus y equals 1. Notice that this went in for the x, but everything else is exactly as it was. All right, I'm going to distribute now. I got 10 plus 2y plus y equals 1. Combined like terms, I got 3y there and a plus 10. Right, that's positive 10. That's 3y equals 1. Subtract 10, I got 3y equals -9, and divide by 3, y equals -3. So if you look at this, right, I'm going to take this back up to my original problem now. Y is -3, so what I really have is x equals 5 plus -3, that means x equals 2. Final answer is 2, -3. Okay, last 3 here, 75% done. All right, looking at number 10, I see an x by itself, right there. That tells me substitution. So where x is, I'm going to put a -8y. So really, I'm taking this, and putting it in where the x is. I got -8y, then plus y equals 14. Combine like terms, I got -7y equals 14 by, and I got y equals -2. Okay, my first equation said x equals -8y. So -8 times -2, x is positive 16. That's 16 comma -2. Okay, I'm looking at number 11 and I see x's, y's, and numbers lined up. I'm thinking that's probably elimination. I don't know, because one x is positive and one is negative. I think I'm just going to use those because that's what I need to be anyway. So I'm going to choose to cancel the x's. Just going to multiply the bottom by 2 and the top by 3. So on the top, I get 6x plus 12y equals 36. On the bottom, I get -6x, so there's our stuff that will cancel, plus 6y equals, 126. These cancel, add these, I get 18y, and I got 166, 162. That sounds like if I divide by 18, then y is going to equal 9. All right, I'm going to go back to my original equation with it. Then I'm going to pick the first one because it's got all positives and stuff. I've got 2x plus 4 times 9 equals 12. So 2x plus 36 equals 12. Got to subtract the 36 off. 2x equals negative 24. And divide by 2, I got 2x, or excuse me, x equals negative 12. So final answer here, negative 12, comma 9. That one's kind of ugly. All right, last problem. Kind of a mess again, but I see x's, y's, and numbers. X's, y's, numbers. Seems to me like elimination. You got a negative 1y and a negative 2y. Well, the negatives don't help me, but I could turn one into a positive 2y, and it would work in one step. So I'm going to take this and multiply by negative 2. That's going to give me negative 6x. But here, two negatives cancel to make it positive 2y. So this and this will cancel. And then I got, again, two negatives make that a positive 4. So I'm going to put 5x and negative 6x here is going to give me negative x. Negative 2, positive 2 cancel. Negative 1 and positive 4 give me negative, back that up. Negative 1 and positive 4 give me 3. So if negative x is 3, then positive x must be negative 3. Last step. Let me go back up to one of these. Let's use the top one. Doesn't matter. Put that negative 3 in for x. So I got 5 times negative 3 minus 2y equals negative 1. So this is negative 15 minus 2y equals negative 1. I'm going to add the 15 to the other side. So I got negative 2y equals positive 14. Then I'm going to divide by negative 2. I get y equals negative 7. Okay, final answer. X is negative 3. Y is negative 7. Excuse me. All right, that's actually it for all the problems. As you notice, some of them were substitution, some elimination, some you could have chosen both, but there seems to always be one way that works a little bit better than the other. By the way, if you're watching this video, I'm going to give you a little bonus credit tomorrow if you can write the bonus phrase on your quiz. That bonus phrase is Crosby is back. All right.